Welcome to gas stoichiometry. We'll solve gas problems together. Okay, we're just going to do the simple gas stoichiometry problem where you're given one reactant and we're going to figure out how much product. Difference between what we've done before and what we're doing now is instead of just being able to go from grams to moles or moles to grams, we're also going to have to incorporate the ideal gas law to calculate a volume. So in this problem, we're asked to figure out how many liters of carbon dioxide can be generated when we burn 100 grams of pentane, C5H12, under these conditions of 25 degrees Celsius and 1.02 atmosphere. So, like always, the first step is going to be to write a balanced chemical equation. And we have that right here for the combustion of pentane. So write down what you're given and write down what you're looking for. That's always going to be the first step. In this case, we were given 100 grams of C5H12, so I would write that right underneath C5H12. Okay. I would also write down what we're looking for, which is how many liters of carbon dioxide, and it gives us some conditions for which to calculate that at. So, going back to what we're given, whenever we see grams, we know that we can figure out how many moles, and as we know, everything reacts in mole ratios. So 100 grams of C5H12 will give us 1.39 moles. Okay, I did the work for that down here, so molar mass 72 grams. That's how many moles of pentane we have. Now, to figure out how many moles of CO2 that's going to generate, we have to use the ratio from the balanced chemical equation, which is you get 5 moles of carbon dioxide for every 1 mole of pentane that you combust. So we incorporate that ratio to find that we would get 6.94 moles of carbon dioxide that could be produced if we burn all of the pentane. So we put that here. We know how many moles of this substance we have. And the difference, again, between before, we were just doing gram stoichiometry, and now we're incorporating volumes, and especially if we're not at STP, we have to use the ideal gas law. All we do is take Pivnert and rearrange it to solve for V. So it becomes volume is equal to the number of moles times the ideal gas constant times the temperature, all divided by the pressure. So we plug in that 6.94 moles. We use the R value for atmospheres. Make sure your units are in atmospheres for pressure if we're going to use that value. We plug in the temperature, we convert it to Kelvin, and incorporate the pressure, and we would find that you could make 167 liters of carbon dioxide from 100 grams of pentane. And you can compare any two substances in a chemical equation as long as you use the appropriate mole ratio from the balanced chemical equation. Okay?